Hello, honors students. Here we have the vertical angles theorem, and here I'm going to prove it. Okay, so if we can follow along this proof, it's going to, number one, strengthen your understanding of vertical angles, and number two, it's going to strengthen your understanding of a two-column proof. Okay, so what do we have given? Well, we have these two lines. Okay, I'm going to clean it up just a little bit so we can kind of see it a little bit better. Okay, we have these two lines intersecting, and then four angles are created as a result. That's always what it's going to be the case with two intersecting lines, okay? So now, what do we know? Well, take a look here. If we know supplementary angles, that's kind of like our building block here. We need to understand supplementary angles in order to build off that information, okay? Use deductive reasoning and establish what vertical angles are, okay? So let's look at what's given. Given angle 1 and angle 3 are vertical, okay? We don't know what, we know vertical angles are congruent, but we're trying to prove that right now. So we can't just say angle 1 and angle 3 given and then say, oh, it's given that they're congruent. No, we need to prove it. So what we need is we need to understand supplementary angles, okay? So let's say angle 1 and angle 2 are supplementary. I'm going to abbreviate just sup, okay? Why? They form a linear pair. Okay, we talked about that earlier, but linear pair just means we have two lines two angles, a pair, forming a line, linear pair. Okay, they form a line. As we know, a straight angle, as I demonstrate here, has 180 degrees. Okay, and those two angles are splitting that line, so they add up to 180 degrees. Okay. So now we can write, if we know that they add up to 180 degrees, let's write that. We'll say angle 1 plus angle 2 equals 180. Okay? So we know that bit. And why? That's the definition of supplementary angles. Okay? Now, I'm going to do something here. I am going to subtract angle 2 from both sides. Okay? And you're probably like, why would you do that? Well, I'm going to just kind of show you why I would do that in a second. I'm kind of combining steps here, but I want you to be able to see that we're getting angle 1 alone. If we're trying to prove angle 1 is equal or congruent to angle 3, then we need to know what angle 1 equals. Okay? That might help. Okay? So we're going to subtract angle 2 from 180. Okay? And we're just going to leave it like that. What property do we use? Of course we use subtraction property. Okay? Subtraction property. Okay, now, what's another piece of information we have? Okay, well, if we found stuff about angle 1, we should probably find stuff about angle 3. So look at angle 3 and 2. What do you notice about them? Well, guess what? They too form a linear pair. Okay, they're split up and together they form 180 degrees. So let's write that. Angles 3 and angle 2 are sup. And we're just going to basically follow the same pattern that we did with angle 1 and 2. They form a linear pair. Okay, two angles forms a line, linear pair. Okay, now we know that angle 3 plus angle 2 equals 180. Okay, and that's the definition of supplementary angles. Okay, and again, let's subtract angle 2 from both sides. If we found angle 1's measure, let's find angle 3's measure. So we do angle 3 equals 180 minus angle 2. And that's the subtraction property. What do you notice? Well, take a look. We got this and this both equal to each other. So let's substitute the value. Let me go to orange here on my pencil. Let's substitute the value of angle 3 in for this if they're equal. Okay, so what does that result in? We get angle 1 is equal to, or I'm going to put congruent here, okay? Angle measures that are the same are congruent, okay? So angle 1 is congruent to angle 3. And what do we use? We use the substitution property, okay? So see how we used the two-column proof with just the definition of supplementary angles and the subtraction property and substitution in order to prove that vertical angles are congruent.